Hi everyone, in Algebra 3, this is going to be your new material for lesson 61. This lesson is going to be a little bit longer, so please bear with me. And what we're starting to do today is to go over something called statistics. So for lesson 61, the first thing we're going to go over is called single variable analysis. And for this one, we are going to be doing things called finding the range, the mean, the median, and the standard deviation, and then sometimes the variance. I want you guys to make sure you guys have a calculator because we're going to actually be using that. Now, I'm going to be using this type of calculator, the TI-30XA, and I'm going to show you how you input your variables so that you don't have to do your work by hand on these problems. But if you have a different type of calculator, you're probably going to need to look that up to see how to do that. You will need to know how to use these calculators for when we test again, though. So you can pay attention to the different buttons that I use. I'll write down some information too so that you can remember the different things that we're going to use on the calculator. Okay, so you guys should know how to find the mean of something. That's going to be the mean old average, meaning that you just find the average of the numbers. Finding the range, you guys know, is the largest number minus the smallest number, and then that would be your range. Your median is your middle number. Your mode is the number that shows up the most. And then standard deviation is going to be the statistic that mathematicians use to get a feel for how much the measurements are spread out on either side of the mean. So it has to kind of do with the mean and then the different spread of the numbers. So if you look here, this would be our mean, and then this is the spread of the different numbers. And we're going to be using something called the standard deviation to find that spread. The variance is to find the average of the squares of the deviations. So if you look at this chart here, this gives you how far each value is deviating from the mean. And it's basically the average of those deviations, average of how far it's deviating away from the mean. And they're taking each of those, squaring it, and then dividing it by 4. And that's going to be what your variance is. The standard deviation is basically the square root of the variance. So it's kind of like the average of the distance away from the mean each point is going to be. And we're going to use our calculators to actually solve for both of those, so we don't actually need to do this portion of it. But what we're going to do now is we're going to look at just something called the standard deviation. And we're going to use our calculators to find the mean and their standard deviation. So what you want to do first is anytime that you're going to actually start entering something into your calculator, you want to make sure that it's clear. So you're going to do second 7. If it says error, that means there was nothing entered in it. So to clear the calculator, you're going to use the mode second and then the number 7. Second 7. So second 7 clears the calculator. And then once you've done that, then we're going to start entering our variables. And when you're entering variables, so entering variables, you are going to use this button right here, which is the summation plus button or the E plus button. And you're going to press that after each time you enter a variable. So you'd enter a variable, then press the E plus button. You enter a variable, then press the E plus button, and so on. And then you'll end with the E plus button when you're done. And that should tell you how many variables you've entered. So I'm going to look at this right here. I'm going to do 12, E plus, 7, E plus, 15, and then 10. So then at the end, it says that there's 4 variables entered into the calculator. I count there's 4 variables. So I know that I've hopefully entered them correctly. Then to find the mean, once you've entered in all of your variables, we are going to be using the second x squared button. Second x squared. So second x squared, that actually tells me what the mean is going to be. So for this problem, the mean of those 4 numbers is going to be equal to 11. Now I could have solved for this by hand if I would have taken all my numbers added them together and divided by how many I had. So if I tried it by hand, it would be 12 plus 7 plus 15 plus 10 divided by 4. So let's try that. 12 plus 7 plus 15 plus 10 divided by 4. Well, look at that. It gives me 11. So I'm showing you that this could also be done by hand, not just using the calculator. But now that I've already entered my variables into the calculator, it says stat at the top means that they're still saved. Then we're going to just find the standard deviation. And the standard deviation, you're going to do second divide. So standard deviation you're going to use the variable or the calculator second divide, and that will give you your standard deviation. If you want to find the variance from that, you have to do it after the standard deviation, and you just hit the x squared button. So if we wanted to find the variance, it would be that squared, but I'm going to write this down. So my standard deviation I got was 2.92 approximately. The variance would be that squared, so it would be 8.5. So now, if I wanted to do this by hand, I'm going to show you how to do it by hand. It's not the optimal way to do it because it takes a lot more time, but I can show you that it can be done. So what you would do is we would start by solving for the variance, because that's how you find the standard deviation, is from the variance. So remember, the variance is going to be the square of the distances, the square of the average distance, the distances away from the mean. So what I would need to do is I would need to find the distance each point is away from the mean. So 12 to 11 would be 1, so that'd be 1 squared. 7 to 11 would be 4 squared. 15 to 11 would be 4 squared. 10 to 11 would be 1 squared. And then I would divide that by 4. So what I would end up with would be 1 plus 16 plus 16 plus 1, and then that all divided by 4. Well, look at that. That gives me my variance. My variance would be 8.5, and that matches what I got in the calculator. The standard deviation is the square root of the variance, which means whatever I got for there, I'm going to square root it, and look at that, it gives me 2.92. So again, this can be done by hand, but it also could all be done in the calculator so that you don't have to memorize all of that. You just need to memorize how to use your calculator. So this is called single variable analysis. So what I want you to do is you can actually go through, and I want you to actually try number 9 in your lesson, and then we're going to go over that problem together. And I can do this problem again by hand, or we can just do it in the calculator. It's kind of up to you what you want to do. I will show you both ways just for the learning purposes, but from now on, after we do this, we're going to do them all in the calculator. And if you need some reminders for what to use in your calculator, here they are. So I'd like you to try this problem and then unpause it when you're ready to try it with me. So what I'm going to do first is I'm going to do second 7 and clear the calculator. And then I'm going to start by solving for the range. So I have the numbers 3, 4, 5, 7, and 8. I've already put them in order. So for number 9, I'm going to start with solving for the range. So that would be biggest number minus the smallest number. So my range is going to be 5. Now for the, I'm going to do the mean later, but I'll do the median is the middle number. So 1, 2, 3. So the middle number, so the number that falls between 5 and 7, can do 5 plus 7 divided by 2. That's going to give me 6. The mode is the number that shows up the most. This case, the only number that shows up multiple times would be 8. And now I'm gonna do the mean, the standard deviation, and then the variance. I'm gonna start by doing this in my calculator to remind you how to do it. So I'm gonna start by entering all my variables. So 3, 4, 5, 7, 8, and 8. So I have 6 variables that I've entered. Now to find the mean, I'm gonna do second x squared. So that means my mean is gonna be 5.83. My standard deviation, I do second divide, should give me 1.95. And my variance is that squared. So it'd be approximately 3.81 if I rounded to 2 decimal places. So now what I'm gonna do though is I'm gonna show you how to do this by hand. And actually by hand, it's gonna be really difficult because our mean has a decimal in it. So this does make it a little trickier. So I'm actually not gonna do this one by hand because I would have to find the difference between the mean, which is this decimal number in each point, and then square it. And that would be kind of difficult just because it's it's a decimal number. So we're not going to do that one. We're going to just leave it as is, and that's how you're going to use your calculator to do that for number 9. Okay, so that's done with single variable analysis. Make sure that you recorded all of that information for how to use the calculator. Even if you're not using that type of calculator right now, I still want you to get used to using that. So please make sure that you guys have that recorded somewhere. The next thing we're going to look at is something called normal distribution. And what this is a theoretical frequency distribution that is sometimes approximated by data that is collected experimentally. This is going to have to be with like a large group of analysis that you are given. And for normal distribution, for this to be true, the mean, the median, and the mode all have to be the same. So the average number, the middle number, and the number that shows up the most is all going to be the same in order for normal distribution to work. And we are going to be looking at the empirical rule, or the 68%, 95%, and 99%. So we will know the normal distribution for 68%, for 95%, and 99%. And what this has to do is with the standard deviation. So you are going to write this part down. So 68% of the variables, when it's under normal distribution, are going to fall within 1 standard deviation of the mean. So you would take your mean and you do plus or minus 1 of the standard deviations. So the mean plus or minus 1 standard deviation. If you look at this chart, it's showing you that 68% are going to fall within the mean. So the mean is 100. And then the standard deviation is 3. So between 103 and then 97 is where 68% of the data is going to fall. Now, it could be a wider distribution like this, where 68% with the standard deviation is now 10. 68% is going to fall between 110 and then 90. So this is what a normal distribution looks like for 68%. So it's the mean plus or minus 1 standard deviation. For 95%, it's going to fall within 2 standard deviations of the mean. So again, if this standard deviation is 3, it would be the mean plus 2 times 3 and the mean minus 2 times 3. So 95% of the data is going to fall between the mean 100 plus or minus 6. So 106 and then 94. That means 95% of the data falls between those 2 points. And if it's a wider distribution, then the standard deviation is 10. That means it falls between 120 and 80. So if you kind of looked at this, it's like test scores. If the standard deviation was 10, that means like the scores deviated very far away from the mean. So obviously going above 100, that's sometimes possible, maybe like on your final. If the standard deviation was 10, that means the average people that deviated away from the mean was about a score of 10. So that means 95% of the people fell between an 80% and 120% on the test. So obviously, as it gets wider, more people are going to fit within those 2 data points. And then if you look at 99%, again, as it gets wider, more and more people are going to fit within that percentage. So it's going to be the mean plus or minus 3 times the standard deviation. And this is the portion that you have to have written down because that's what we're going to be using. So again, if it was the standard deviation was 3, that would be the mean plus or minus 3 times 3 or 3 times 10, depending on what your standard deviation is. Okay, so we're gonna do this example right here, which is 61.2. It says the mean of a distribution that is approximately normal. So again, those were the normal distributions, and that's what we're gonna use. So you need to know the empirical rule again, which is shown right here. So the empirical rule 68, 95, and 99. So 68, 95, and 99. Those are the 3 percentages you have to know. So what we're going to do now is we're gonna apply it. So this gives us that the mean is 100. So the mean is 100. And the standard deviation is 5. So that's always represents your standard deviation. And it says use the standard deviation to tell how the data are distributed with respect to the mean. Okay, so what that means is they want us to do this right here. So we're going to start out with our 68%. Our 68% of our data should fall within the mean plus or minus 1 times the standard deviation. Well, our mean is 100 and our standard deviation is 5. So if I do 100 minus 5, that would be 95. And then if I do 100 plus 5, I would get 105. That means that 68% of my data is going to fall between the points of 95 and 105. Then I'm going to go on to 95. Now 95% of the data is going to fall within the mean plus or minus 2 standard deviations. So I would do 95%. That's going to be the mean plus or minus 2 times the standard deviation. Oops. Now my mean is 100 again. And I'm going to do 2 times 5. Well, if I do 100 minus 10, that's going to give me 90. And then 100 plus 10 is going to give me 110. Which means that 95% of the data is going to fall between 90 and 110. And then lastly, so again, as you add standard deviations on, more and more people are going to, more and more percent is going to fall within those 2 points. So then for the last one, it's 99%, which would be, so 99% would be the mean plus or minus 3 times the standard deviation. Our mean is 100, and then it would be 3 times 5. So I have to do, first one would be 100 minus 15, which would be 85. And then 100 plus 15 would be 115. So I'd say 99% of the data is falling between 85 and 115. And that's how you complete this problem here for 61.2. So what I want you to do is now I want you to try number 10, which is very similar to the one we just did, and I'm going to follow it almost exactly. So if you haven't tried it yet, I want you to pause this video now and attempt number 61 or number 10, and then unpause it when you're ready to start with me. So number 10, we have the mean of a distribution that is approximately normal. So again, that's going to use our empirical rule of 68, 95, and 99. My mean they give us is 65. Standard deviation is 3. And then it says use the standard deviation to tell the data are normally distributed with respect to the mean. So again, I'm going to follow the same thing. So 68, and then 95, and then 99. So I know that for 68%, it's going to be the mean plus or minus 1 standard deviation. So I have 65 plus or minus 3. So 65 minus 3 would be 62. 65 plus 3 would be 68. So that means 68% are going to fall between 62 and 68. Then I'm going to go to 95%, and I'm going to do 65 plus or minus 2 times 3, which would end up being 65 plus or minus 6. So this would fall down to 59 and 71. Then for 99%, we're going to do the mean plus or minus 3 times the standard deviation. So fall 3 down would be 56 to 74. And that would be your result. Okay, so that's how you do number 10. So normal distribution and just plugging in your variables into these equations that you're going to have memorized with the percentages. The next thing we're going to look at is called a stem and a leaf plot. You have seen these before, and this is something that you're going to see probably on your standardized testing. So what this represents is going to be, your stem is going to be your first number. So in this case, it would be your tens digit. So this represents 90, 96, 95. The leaves represent your second number, which is your units digit. This is just your representation. To create it, you would just list all your tens digits and then list all of your units digits next to it. So for number 11, this one asks you to create a stem and a leaf plot. So what I'm going to do is I'm going to just list all my tens digit, and I'm going to start with, so my stem and my leaf look like this. So if you haven't done this, I would pause this and try it on your own before you follow me. I'm going to start with 3, then 40, then 50, then 60. So I'm going to go through, I have 30 and then I have 31. So 30, then 31. Then for 40, I have 40, and I just have to go in order. So 44, then 42, then 47. For 50, I have 55, then I have 57, then I have 53, and then 52. Then for 60, I have 62, and then I have 69. And then if you were trying to find like the mean or the median from there, you would want to put them in order from smallest to biggest. Okay, so that's how you make a stem and a leaf plot. Pretty simple. The last thing that we're going to be making is something called a box and a whisker plot. And in order for you to do a box and a whisker plot, what you're going to have to do is you need to be able to divide all your variables into 4 equal groups. So if you don't have a multiple of 4 variables, then you're not going to be able to do this problem by hand because we're not allowed to use our graphing calculators. So just make sure before you even start the problem, you can always find the mean but you would not be able to find the other data to create your box and a whisker plot. So always count how many numbers you have first before you actually start doing all the work. So the first thing you're going to do is you're going to be creating a plot that looks like this. Oftentimes when I was in college, this is how our professor would always show us our scores, the spread of the scores on our tests. They would show us what the median score was, and then they would show us the minimum score and then the maximum score that someone scored on a test. And then what Q1 is basically the median of the first 2 groups, because remember you're splitting into 4 equal groups. So the median of the first group is Q1, that starts your box. The median of all of the groups is going to be in the middle, and then quartile 3 would be the median of the last 2 boxes. So obviously there's people spread all over, and there's equal number of people in each of these groups, if that makes sense. So what you're going to be doing is you're going to be doing all of this by hand. If you had a graphing calculator, you could actually do this even easier, but we don't have that, so we're going to do this all by hand. So what we're going to start by doing is we're going to look at example 61.3. And what we're going to do first is we're going to start by listing all of these variables from smallest to biggest. These are already listed for us in smallest to biggest. And then I need to count to make sure I can even do this problem. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 8 equal groups. So I'm going to start by, 8 variables, which can be split into 4 equal groups. So that would be contain, the first group would be 16 and 22, and then it would be 28 and 33, and then 35 and 40, and then 50 and 120. Now what I'm going to do first is it says to find the mean and the standard deviation. So I'm going to start by finding the mean using the calculator. Remember, second 7 is going to clear the calculator. Then I'm going to enter my variables. So 16, 22, 28, 33, 35, 40, 50, and 120. So I have 8 variables. Then I'm going to use second x squared to find the mean. So I know my mean is going to be 43. And then my standard deviation is going to be second divide is going to be 3.07. Okay, so I use those to solve for the mean and the standard deviation. Now what I'm going to do is going to find the minimum number. Well, the minimum value is 16, so this is my minimum. And then my maximum value is going to be 120. Then I'm going to have to do my Q1. So Q1 is just the median of the first 2 groups. So it's the middle number between 22 plus 28 divided by 2. So my Q1 is going to be 25. The median between 22 and 28. Then my median between 33 and 35 would be 33 plus 35 divided by 2 would be 34. And then my Q3 is going to be the median between 40 and 50, which would be 45. So now to create that box in the whisker plot, that looks like this. All your variables are not there. So you would start by putting in, this is not going to be drawn to scale now. So this is part of your answer. And then this is going to be how you're going to create the box. So I'm going to start with my minimum value. So minimum is going to be 16. So that starts the whisker. And then 16 to 25. So this would be 25. Would be my Q1. Here's my box. Now the spread between 25 and 34 and 34 to 35. So so technically this would be a little closer to here. So we can do 34 is my median. Q3 is 45. And then my max would be all the way out here at 120 would be your max. So it's a box with whiskers that come out of it. That's why it's called a box and a whisker plot. And that would conclude the example. So now what I want you to do is I want you to try number 61, number 12, and then we're going to do the problem together. Okay, so for number 12, I'm going to start by, I have to list these in order from smallest to biggest, and then I need to make sure that I can even divide this into 4 equal groups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. Okay, there's 12 numbers, so I can split that into 4 equal groups. I'm going to start with the lowest number would be 30, then I think 43, and then 50 would be group 1. After 50 would be 58 and 58, and then 60, 61, 62, and 63, and then 65, 68, and 72. So that would be my 3 equal groups. Now what I'm going to do is I'm going to start with, this would be my minimum value. The median between 50 and 58 would be 50 plus 58 divided by 2 would be 54. Would be my Q1, the start of my box. 60.5 would be my median. And between 63 and 65 would be 64. That would be my Q3. And this would be your max. So really it's just finding the medians is all you're doing. So I would start with 30, and this is my minimum. Then go to 54, which is my Q1. Then make my box. Now do 60.5, which would be my median. 64 would be my Q3. And then my max would be 72. That would be my max. So that's your box and your whisker plot. And then you're just left with solving for the mean and the standard deviation. So again, I'm going to clear my calculator a second 7. I'm going to input the variables. So 61, 58, 43, 30, 72, 68, 50, 63, 62, 58, 65, and 60. So there's 12 variables in the calculator. Then I'm going to do second x squared, which would be the mean. Would be 57.5, and then the standard deviation is second divide, so that would be 11.06. That's all going to be a part of your answer. I know that was long, but that concludes your lesson 61. That's all your new material. Hope you guys all have a great day. Bye.